It's time for Myth of the Week.
All right, so really funny story with this week's myth. What happened was I was trying to find some conductors that were just pulled straight through, some equipment grounding conductors that were just pulled straight through, and I saw these like loops in this. I was just getting ready to leave for the day, and I was walking out the building, and I was like, oh, there's some conductors pulled straight through. That'd be a good one. So I took a picture of it. And then I didn't even look at the picture or anything. I just thought that all the conductors are pulled straight through. The one thing I noticed was there was bonding bushings on all the conduits exiting that enclosure. And I started thinking to myself, like, I bet you those guys pull a little extra slack so they could bond them just in case they needed them, you know? And so this is just temporary or whatever, so it's probably not too big of a deal. But I went over there and I went to poker night and everything, and I posted up my myth and everything, and I did it on a break, on my poker break. And so then I got home that night about 9 o'clock or something, and I went and I looked at it, and then that's when I realized they was missing a ground. So I didn't even notice that. I thought they all three had grounds in them. So if everyone thought I was intentionally trying to take a picture of some kind of violation, I was not. I did that by accident, but I was trying to show how this myth gets commonly misinterpreted. And Juan's jumping over on the YouTube side, so yeah, there you go, man. Yeah, Willie, yeah, he'll be happy about that. But it's pretty awesome to be able to do these myths. I've actually had inspectors before tell me that I had to bond those grounding conductors to the enclosure, regardless if they're pulled straight through. And that's the reason I decided to pull this myth this week. And like I say, I really love the fact, like, every time I run into these inspectors, they're always saying how much they like the myth of the week and how they like learning and how they like me bringing these to light and stuff. And then especially bringing like James in, and I feel like so much confidence with James in the room, because I know that I can basically ask him any questions and he will 100% make fun of me as much as possible. And that's good. You know, that's how I learn. You know, it's like, all right, no, you know, I'm putting myself out there. And James is a good sport about it. He doesn't hammer me too bad. I usually get destroyed by a bunch of code guys, but at the same time, it's like, I'm not a code expert as such. You know, I mean, I've claimed that I was a little bit better than other people, but at the same time, it's like, you know, they say, Peyton Manning says, being a code expert is when you've done something for more than 10,000 hours. So I've definitely done code for more than 10,000 hours. So I'm technically an expert.
That only happened once.
Yeah.
That ain't right.
Yeah. Yeah. I like it. You're just a little brash, you know, and I'm like, all right, I learned my lesson. But at the same time, it's just really awesome to have James bring forward like all his learning management system, and we're actually still coming with the NEC deathmatch as soon as we can. It could be this fall. It might be as early as late summer. We're not sure when it's actually going to be able to be dropped, but when we drop it, it's going to run through start to finish. We ran a few different rounds of the deathmatch, and we know that we can do the time limit. We know we can do, you know, the scoring, all the different stuff. We've already went through all the bugs on it and stuff. So I really appreciate you kind of powering through that, you know.
Yeah, everything's going to be awesome when we get there.
Yeah, I haven't seen David tonight, Juan, but he usually pops in. No, who we're expecting is we're going to expect old Daniel J to come sharkle Stallcup on the quiz.
Oh, yeah. All right. Well, I put a few little extra things in here for everybody to look at, and I did it in a systematic way, like I always do.
Nice.
So
yeah.
The first thing I wanted to look at was 250.96A and just the general requirements for bonding other enclosures. And what it tells you is where you have metal raceways, cable trays, cable armors, blah, blah, just goes through it all. and it says that are to serve as equipment grounding conductors, and this is the part with or without the use of wire type supplementary equipment grounding conductors shall be bonded if necessary to ensure electrical continuity and of course the capacity to conduct the fault current likely to be imposed on them. Okay, so everybody that's done anything in electrical for any amount of time, they're very familiar with this portion here that you got to ground bond everything that's metallic. Okay. Now, the next part, yes, I'm in the background working on some II. Awesome. All right. And then if you go look at 25109, this is where it gets into the metal closure portion of it. And it says they shall be permitted to be used to connect bonding jumpers or equipment grounding conductors or both together to become part of the effective ground fault current path. Now, some would look at this and automatically just assume that I would have to take on that. Yeah. Go back, we're looking here. This is where you get into bonding other closures, and you'll notice right there we get to our metal raceways. Then,
yeah, and I like how you connect kind of those code loops too. That's pretty sweet.
Well,
I know you do that in your book too.
Anybody that's ever used our publications knows 100% fact we're the only ones that really do this. Is when you go in and you're looking at things, we always have code loops. We also have standard loops from other standards that you might want to look at, and we put them in a systematic way so you can look at each one of them sections and see what we're trying to tell you. You know, right. Even though we write it in the text, when you get to the illustration, you're limited so much that you can put in an illustration. So what we do is we put all the sections there. And if you go look at other ones, you can go look at all the other publications out there. They usually have an illustration. They'll have a section there, but they don't have all these loops and everything and pointing out different things to all these different sections. And I understand why they don't do it, because when you go back to update that book, you got to check all that stuff, you know. Yeah. And I'll tell you,
you've had a couple in 2023 that you missed a little bit, and you know, like I say, I don't think it's that big of a deal. What I like about it is when you're going to take an exam, you instantly see these loops. So you instantly see like 3 different sections, and it doesn't make you. It gives you that direction. Like when you're going to take that exam, you're able to just be like, I know it's somewhere in 250.
Oh yeah.
You know.
It's just like we missed one. We had 250.24C1. There was no change to the text. All they did was move it down one section to D1 right. instead of C1. I mean, and it, you know, when you're doing a code change publication and you're trying to get that whole thing ready, you know, because the last portion comes out and you've got about, by the time September gets there, you've got about 5-6 months to get that publication ready. So you're going back trying to check everything. And we just happened just to miss it. They moved that section down one, you know, and, but I can tell you this, we didn't miss it in the other publications. You know, we caught it after that, but that book had already gone out to publish, and we had, you know, a section that was wrong. It got moved down one. We didn't see it, you know, because it wasn't like a change that we were referencing.
Right.
So, but going back to this, here's your types of equipment grounding conductors. You can look there. I didn't list them all. I just put a couple there because it looked like that was EMT in the picture. That's part of your equipment grounding conductor right there that could be used. So, yeah, the equipment grounding conductors were pulled straight through. And then it also told me when I looked over it based on the fittings and the metal raceway right back here in 250.96A, I'm permitted to do that. Okay. Yeah. And the equipment grounding conductor could just go straight through. And then I looked at the continuity of the equipment grounding conductors and attachment and boxes. Okay. And it talks about connection splices, your continuity of the equipment grounding conductor. I mean, it just depends. If you want to take and bond everything in there together, guess what? You can do that too. Or I could just have them equipment grounding conductors coming in, and I can use the metal raceway and the approved fittings that are listed for that. Okay. So that's the way I would view that. and that gives you all the sections there that you would want to look at, and you could see that the myth is busted, that yeah, those equipment grounds could be pulled straight through, because 250.118 allows me to use that as an equipment ground, and then 250.96A gives me the permission for the raceway itself and the connectors for the bonding.
And 250, 148 C.
Yeah, all that. That's what I'm saying. It's just everything is tied together right there. That's everything you need to look at to give you the permission of however you want to wire. Basically, is
Yes,
what it
sir.
comes down to.
Myth busted. So awesome. Thanks for jumping in the house, David. We always appreciate having David and Mr. G hang out in the house. And thanks for all the new guys that are jumping in here. Appreciate it. So we'll. How many more weeks do we have for the? Somebody was asking me because they want to go to the thing.
What I'm going to do is because there's so much that goes into the full calculations, I'm just going to do all the residential full calculations this week. Next week, we'll go into the commercial, and then I'll have the homework for it. And then we'll answer that after that the next week, and then I'll do all the full calculations that I can for commercial. So I'm just not going to give any homework for the full calculations, because it gets convoluted on the screen when you're looking at it. So I decided to do it this way. So I hope everybody's okay with it, but you can go back and you can look at all these calculations. We're going to do this week, we're going to do the optional calculation for dwelling units, and then we're going to do the multifamily dwellings. We'll do the standard and optional, and then we'll do mobile homes, standard calculation. Then I'll do a mobile home park with the optional, and that's what we're going to cover tonight. Okay.
All right. Well, don't forget to smash that like button and subscribe to the channel. We're trying to hit 1,000 subs by summer, so we're getting there. It's spring, so you got time, but smash that like and subscribe to the channel.
Amen. All right, let's cue it up. All right. Okay. Right here, what we're going to get into is we're going to start looking at the optional. We did the standard last week, and we give you a lot of stuff here to look at. And you're going to see we give you all the loads. We separate them here so you can figure out how to do all this. Now, on the bottom left-hand side, you'll still notice we still have the dot that's there for sizing the phases. When you get ready to do the neutral, you're going to have to go back to the standard calculation to get that. Okay. Now,
hey, real quick, Juan has a comment for you.
Sure.
Yeah, that's a good comment, Juan. A lot of field electricians don't.
They don't
look at that.
And that's one reason that we've taken the new grounding and bonding book that's going to be coming out here hopefully by the end of April, 1st of May, somewhere in there. We've gone in, and I think everybody's really going to like this. Matter of fact, since we're getting questions, let me look here real quick. I have taken and done a lot of the illustrations here so everybody can sort of see just exactly what we've done. Let me look here and see what I've done with it. Here's a PDF. Okay, let me open this up and everybody can sort of get an idea of what you're going to see. Now, if you see a mistake in here, I don't want to hear anything about it because it hasn't been completely edited yet. We're in the process of doing that. So, but this will give everybody an idea of what you're going to see that is going to be coming up in our new stuff here. So here will be the new grounding and bonding book. And as you come down and look at this, I want to get into some of the other stuff here. But like this is a good example here where we're showing the effect of ground fault current path. This is just getting you started. But you can see how we've drawn the panel boards, the disconnects, the motors, everything. And we're showing all the grounds and everything, how they're connecting inside. So we've made quite a few changes to update these. But let me go over here and I'll show you some really good ones here. Get down here where we start looking at, let me go down here. Let's see, I want to get about right in here. I think I want to be. Yeah, we'll get in right here. Okay. This is where you get into like your grounding electrodes and stuff. And you'll notice in the colored version, you're going to be able to see we've colored all the wires. So you're seeing the wires go over there. They'll be in green. You come over here, you pick up your concrete encased electrode. You pick up your ground ring. You'll notice we've done everything to show where everything's connected. It is really going to be awesome the way that this is done. Another thing that we've done here, and I think this is pretty good here. If you look at the top left-hand side, we talk about the supplemental electrode and everything. And I want to point out, you're going to notice right there where we got the two rods beside each other. We're saying if you had a 6-foot rod to go 12 foot, well, we give explanation behind this, and this is IEEE. Basically, what that's telling you is you're not impeding on the other rod's resistance. Okay.
Yeah.
And
it wouldn't be a code violation unless you went closer than 6 foot. But you're just saying like an engineered prime.
Yeah, if you're out on the job and you see in your engineering prints they tell you to be 12 foot, there's a reason. Okay.
Okay.
And we go through all that. We go through like the next one over there. We've got new drawings here showing you the different softening devices. Just as you go through all of this, you're going to see like this one right here where we get into the auxiliary grounding electrode, showing you all the connections and everything here. And then we're showing you going to the ground rod. Now, one thing you'll notice that we did miss, because you got a white background, like at the top of that illustration, you'll see it's got a dotted line with gray behind it. That's just so you can see the white conductor.
Okay.
So we've done stuff like that. I'll show you. I'm trying to remember just exactly.
Yeah, we did recently do a myth on the water softener one, like if you have to jumper it, and a lot of people don't think you have to jumper it because you only, like the code only says you have to hit it within the first 5 foot of where it enters the building, but you also have to jumper that whatever kind of equipment you have in that line to make sure you ensure continuity in case that water meter, that softener is replaced or anything.
Sure. And this will give you an example, and you won't see this in other publications, but it gives you an idea of the level of detail in the book. This illustration that's on this page on the right-hand side, if you notice right over here, this is a recommended chart, okay, based on the size copper water pipe you have coming in and the maximum size that you can put on that grounding electrode conductor to that metal water pipe. Okay. And this is recommended by the Metal Water Pipe Association or whatever they're called. But we got this from them and we put this in there. And this is what I'm telling everybody is you're going to get to see a lot of things in this grounding book that you're not going to see in others. And the reason is because we've worked for, you're looking at Dad 50 years. He's learned a lot of different things from people in the industry and things that they've looked at from people that have been on the panels that have come in and made comments, I guess you could say, of what they want to see happen. And that's where you get in and you start looking at all of this stuff here. So
Nice.
it's very in depth. I think the illustrations speak for themselves.
Yeah.
They're very detailed. A lot of information is in them. They've redrawn everything from meter bases, panel boards. I mean, you take your pick. It's just
I
loaded with new stuff.
I only have one complaint with your publication.
What's that?
There's a lot of floppy nipples in there. So, all
Gotta
right,
have
I'll
some
let you.
copy.
There you go. All right, I'll let you get back.
Okay.
Sorry for the
So
interruption.
this in here, we get into optional load calculation. This will be based on 220.82. And we give you the information here, and we're going to be looking at doing the general lighting and receptacle load. You'll see we have a 2,800 square foot dwelling unit, 2 small appliance circuits, and 1 laundry circuit. Then you got all your 120 volt loads. You got a 2,600 VA water pump, 1,000 VA disposal, 1,200 VA compactor, 1,600 VA dishwasher, and a 1,000 VA microwave. And then you got your 240 volt single phase loads. I'm just not going to cover everything, but what I am going to show you here is, and I want to point this out, when we were looking at the standard calculation, what is the one thing we did? We looked at it and we would automatically know we needed to start getting rid of some loads. Okay, so
Yeah.
I would get rid of the oven, the cooktop, I'd get rid of the dryer load and the heating and AC. Now, when you're doing the optional, you're going to do it totally different. You're going to take and just add all those loads up together. Okay,
The
so
one thing I do like is I like how you break it down. I feel that you do it in less steps than anybody out there.
well, it comes down. You got to put it in a grouping, and once you
Yeah.
learn the grouping, it's simple. I mean,
Yeah.
calculations to me in the code, they're simple. Once you understand the process and the step by step procedure, it's really not that hard. And I think, I've had a lot of people that have messaged me, been thanking me left and right for doing this series on calculations and saying they actually understand how to find it now and what they're looking for. They said
That's
before that
awesome.
they say hadn't had anybody explain it like this,
Nice.
and that's one of the things we try to do is make it as easy as possible for everybody. So just to
Oh
show
yeah.
you how to do this, step one, you got your general lighting load. We know you're going to look at 220.82B1 and it's going to refer you to 2014J. You're going to take it at 3 VA per square foot, same way you do your standard. So that's going to give you 8,400. Then you got 1,500 VA for each one of the small appliance and laundry loads. That'll give me 3,000 and 1,500. Then if you go look at table 220.82 B3 and 4, I'm just going to add all the rest of the loads together right here. We'll just call it the fixed appliance load. Okay, everything goes left right here. So you just put all those together. It's going to give you 59,100 VA. Now, when you look at 220.82B, what does it say over there? Well, as you look at that section and you read the text, what it says here is this. It says I'm sorry, that's the wrong one. It says for your general loads here, the general calculated load shall not be less than 100%. Now listen to this: of the first 10 kVA, and then 40% for the remainder.
Right.
Okay, so I'm going to take the first 10,000 at 100%, whatever's remaining at 40%, which would be 49,100 at 40%. That'll give me 19,640 VA. Add that up, gives you 29,640 VA. And then I need to determine which is the largest between the heating and AC load. Okay.
Right.
Now, if you look at this, I can already tell you this. It says when I look at 82 C1 and C2, and I come down and I pick up C4 there, it talks about the electric space heating. It says if less than 4 separately controlled units, you take it at 65%. Okay,
Right.
so I'll take the 10,000 at 65%, gives me 6,500. That's larger than 6,000. So just add those up, divide it by 240. That gives you your amperage. Okay.
Nice.
Now, the next thing you're going to do is just look at table 310.16. The next size above that is a 2-aught, which is good for 175 amps. Okay. We
Right.
barely missed the 3-aught at putting that in. I'm sorry, not 3 aughts. It's been a long day.
One
3 aughts, 200 amps. I'm
yeah,
tired. Okay.
it'd be 1 aught, right?
Yeah, 1 aught. Yeah, I just
Okay.
don't know why I'm saying 3 aught. Now, if you look right here and you come down and you look at table 310.12, let's go over and take a look at that and see what it says. Table 310.12, when you pick
So
that,
this is all 2020, right?
yes, it's 2020.
Okay,
Yeah,
because I think
everything,
that's changed. I think that's changed for 2023.
it has, but that's why we kept everything on 2020. 2023 is not updated yet. All right.
Okay.
So when I come over and I look at my single phase dwelling services and feeders, I come down, I was at what, 151 amps, come across, pick that up. The next size above that's 175. And what does it say I can put there for a copper conductor? 1 aught.
Yep.
Okay. So that's how you want to go about looking at this. So let's recap real quick, because we're going to get into multifamily dwellings in a second. And what I'm going to tell you is, once you got the dwelling unit down, multifamily is exactly the same way. It's just you're going to do it by the number of units. Okay.
Nice.
And then you'll remember I said, when I get over and I start looking at table 220.42, that the first 3,000 is taken at 100%. Then I'll take the 117,000 after that, 35%. Anything that gets over 120 after that, then we'll take it at 25%. You're going to see that when we get over to doing these multifamily dwellings. Okay. Now, the other thing I want to point out as a recap here, if it's a standard calculation, we have 6 groups. Okay. You had your general lighting and receptacle load. Then you had your small appliance branch circuits and your laundry circuit. So that's one load we were doing all together. Okay. Then we went and did our cooking equipment loads. Then we did our dryer loads, and everything that was left other than the AC and heating unit, which we'll do separate because that's a non-coincident load. Everything else fell in where? The fixed appliance load. Okay. Then we went heating and AC load, then largest motor load, and that's your grouping right there. Now,
Nice.
when I get here to optional, you're doing all exactly the same thing. You're just going to add everything together except the heating and AC, and then take the first 10,000 at 100%, and anything that's left over at 40%. Then add your non-coincident load between the heating and AC load, whatever's the largest. Add those together, then divide it by your voltage, and that'll give you your amperage. Okay, so that should be the way you want to remember when you're doing these calculations. Now, look at this. And this one here, we're going to have 25 multifamily dwelling units. Okay. Now, we'll look at this real quick, but I want to point out top right hand side. You'll see we'll have a dot there for your phases, and then we'll have the check mark there that's going to be for your neutral. Okay. Just like we did last week when we were doing the standard calculation. Now, we got 25 units that are 1,000 square foot each. We got 2 small appliance circuits for each unit, and we got 1 laundry circuit per unit. And then our 120 volt single phase loads, we got 25 1,000 VA dishwashers, 25 1,200 VA disposals, and my 240 volt single phase loads. You'll notice we got 25 of everything. We got 12,000 VA ranges, 25 6,000 VA water heaters, 20,000 VA heating units, and all the dryers are natural gas. If these were electric, then we would have 25 there to do that. So you may get a test and they'll tell you that the dryers are natural gas. If that's the case, don't worry about that. It's not going to be calculated into the calculation. Okay. So let's take a look at how we would look at this. First, we got our general lighting and receptacle load. Okay. Same thing. I'm looking at 220.14J just like I do for one residential unit. The only difference here I'm doing is adding the 25 units on here. So I'm taking the 1,000 times 3 VA. So that's 3,000 times 25 units gives me 75,000 VA. I've got 2 small appliance circuits for each unit. Each small appliance per 220.52 A and B for the small appliance and laundry unit is good for 1,500 VA. So once again, you've got 2 small appliance. That's 3,000 times 25 units is 75,000 again. Then I've got 1 laundry circuit per unit. Take that at 25 units, gives you 37,500 VA. Add it all up, you got 187,500 VA. Now, those that are following along, go look at table 220.42. Now, you'll notice we're giving you all the sections here, so you'll know where to go find this information. And it tells you, it's the very first one that deals with dwelling units. First 3,000 at 100%. The next one, now, some people mess this up. Some will put 120,000 here. You've already done 3,000 of it, so it's up to 120,000. So it'd be 117,000 VA. Okay, so you'll take 117,000 VA at 35%, gives me 40,950 VA, and then I'll look at my remainder here. It tells me anything over 120,000, I take it 25%. Well, the remaining VA I had was 67,500 VA. Take that at 25%. That'll give you 60,825 VA. Now, if you look at that, it was the same calculation we performed for a single residential unit. We did not do anything different here. The only difference I did here was add the 25 units to each one. And then when I got down to step 3, I was over 120,000, so I had to take and do that additional VA. Okay, at 25%. All right.
Nice.
Yeah. Now, cooking equipment loads. I had 25, 12,000 VA ranges. Now let's go over and let's look at table 220.55. I come down, I pick up 25 units. I come across, and you'll notice I'm not over 12 kVA. And I'm more than 8 3/4, so I'm in column C. You just come down and it tells you it's good at 40, so that'd be 40,000 VA. It's already given to you.
Okay, and so this is a multifamily optional, or is this a multifamily standard?
This is standard.
Okay, gotcha.
This is standard. I think I said that at the start.
I just some people came in late maybe.
Oh, okay. Now, if you look at 220.61. And you're looking at your calculation here, you get into where you got permitted reductions here, okay? And it's going to tell you here that I can take that 40,000 for my ground and neutral conductor at 70%, okay? So I'll go ahead and figure out my neutral here. That's 28,000 VA. Now, if you'll notice right on the right-hand column, we're keeping it step and step here. So when you're doing this on test, I would get used to doing whatever you want to use. We use a bullet and a check mark. But right there, the total load for the general lighting and receptacle load, that is for my phase and neutral. And then when I come down and I look at my cooking equipment load, the 40,000 VA is for the phases, and the 28,000 VA is for the neutral. That's where the bullet and check mark are. Okay?
Nice.
Now, the next thing I'm going to be looking at is everything that was left, because I didn't have a dryer load because it was gas. So I'm just going to add everything else here except for my heating and AC load. Now, we automatically know we're over 4. So we're just going to do every one of these at 75%. Okay? So I had 1,000 VA at 25 units of that. I don't remember exactly which one it was. Let me go back and look. Go back. So we had the dishwasher at 1,000, disposal at 1,200, and then the water heater was 6,000. Okay. So looking at this right here, I'm going to take and I'm going to add these up. I got 1,000 VA, 25 of them at 75% gives me 18,750 VA. 1,200 VA times 25 units at 75% is 22,500 VA. 6,000 VA times 25%, which was my water heater. Take it at 75%, gives me 112,500 VA. Add them up, so that's 153,750. Now let's go back here. What was my neutral load ones? Right here, here's my 120 volt single phase loads in the middle here, and that was my dishwashers and disposal. So I'm going to do those individually right here. Okay. So I'll just pull over the values I've already calculated and leave out the water heater. And that'll give me 41,250 VA. Put a check mark there. There's my neutral load. Okay? So far, pretty simple. All right? Now let's go back and let's look at my heating load here. You're coming back. I've got a heating load here of 20,000 VA. Okay? Come back. I got 25 units there. That'll give me 500,000 VA. That's my phase load. Now I'm just going to calculate what is my largest motor load. Well, I'm looking up there. The largest motor load up there is 1,200 VA for the neutral and the phases. So I'll just take that 1,200 at 25%. It's going to give me 300 VA for each one of them. Then you've done everything at this point. All I'm going to do here is add everything up. I'm going to come over here, take all my phases, add them all up together. That's going to give you 754,875 VA. Take all the check marks that were your neutral load, add them all up together, gives you 130,375 VA. And then I'm just going to divide each one of those by 240 to get my amperage. And my phases will give me 3,145 amps, and my neutral load was 543 amps. Okay. That's a simple. Now, you're just looking at it. You're going to parallel those conductors. We didn't go through all that. We actually have another problem where we go through and show you how to parallel. We don't do every one of them. Okay?
Right.
And here is you won't see us on every one of them, but here's one right here. We said we're going to parallel this 9 times. That's 349 amps for my ungrounded phase conductors. Okay? Now, if I paralleled those 9 times and excuse me, I think that got me.
Yeah.
So if I look at this, I've got 349 amps. Okay. Let's go look at table 310.16 and see what I need here. Okay.
Well, you got to watch out too, because they might turn it up to 363 amps or 368 amps or something, you know?
Well, that's something that Paul would try to do because he didn't understand what he was looking at. So if you go over and you look in your 75 degrees C column, we paralleled that 9 times. You come down, the next size above that is 380 amps, which requires what? 500 kc mil conductors. Okay?
Yes, sir.
Now let's look at my neutral load. It's going to allow me to also put 70% on top of this again. Okay? Now, when you go look at 220.61, we have the load that we did 70% on for my cooking equipment load. Okay? Now you're going to come over because you're doing 70% also, because you get 70% for your general lighting and appliance load also that are there, and all your fixed appliance loads. So we had 543 amps, and it tells you over here you can take the first 200 amps at what? 100%, and then the remainder you can take at what? 70%. Okay? So you take that 343 amps at 70%, that gives me 240 amps, which is 440 amps, and we paralleled each run 9 times. That's going to give me 48 amps. Now, you would go over and look at table 310.16 and automatically you'd say, I put number 8 there. No, you can't. Because if you go look at 310.10H, it tells you they have to be at least 1-aught conductors if you parallel.
Yep, I agree.
So that could be a trick on the test.
Hey, I'm going to have to stop you for a second, James. We got a dun, dun. We're going to have to get a sound effect every time. Dun, 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 dun. Daniel J. shows up, and that's awesome that you are 100% correct, Daniel. I had one question on my exam for the dwelling unit load calc.
When I took mine way back, we actually had to figure up a standard calculation, a single dwelling unit, and then we also had to do a commercial calculation. And then I also had to do a motor calculation. The size, it was 4 motors. We had to size the conductor and the overcurrent protection device. Those were my 3 calculations when I took it.
And it's just like the way we look at it. It's like if you're going camping, We just want to make sure you have a tent, sleeping bag, water, emergency preparedness kit. You know what I mean? Like, you might not use any of them, but you know what I mean? You're going to have a good time camping. So that's the way I look at it.
Now, this one is the exact same calculation, but it's optional. And you'll see that we tell you to look at the standard calculation in problem 14 that we just did for the grounded neutral conductor, just like we did previously on the optional calculation for a single family dwelling. Now, when you come in and look at this, let's see what you do here. Oh, looky there. I'm adding all the loads up again. I'm not doing anything like the standard. I'm just going to take all these loads and add them up. So we've already done the calculation for the general lighting and receptacle load. We said that was 75,000 VA. We had 2 small appliance circuits for each unit. That's 75,000 VA. Then we had 1 laundry circuit per unit for 25 units there. That's 37,500 VA. That's 187,500 VA, which is what we had in the previous calculation. Now you're looking at the cooking equipment loads. You're going to take the 12,000 VA. If they were 10 kVA, you'd take it at 10 kVA. If it was 10.5, 11, whatever. This one, we're going to take the 12,000 VA at 25 units, gives me 300,000 VA. Then we go down our fixed appliance load, same thing. You had 1,000 VA times 25 units, 1,200 VA times 25 units, and 6,000 VA times 25 units. Same loads that we calculated earlier, added up gives you 205,000 VA. And then you had your heating load. The same load we had for the standard calculation was 500,000 VA. Then just add them all up together. That's it. So I add all these loads up together. That gives me 1,192,500 VA. Okay. So we had a single phase 120, 240 volt system. Divide the 240 into it. That's going to give you 4,969 VA. Now, let's go look at table 220.84 and see what it says. It'll tell you there in the table, it'll say optional calculation, demand factors for three or more multifamily dwelling units. We had 25. We come down and look at that. It tells me straight across, I'm able to take and apply a demand factor here of 35%. Okay?
Okay.
So what I'm trying to point out, when we started our optional first, we looked at 220.82 for a dwelling unit. Then if you go over to the next page, then you pick up 84 and it'll say the heading multifamily dwelling. Okay?
Right.
So I'm doing multifamily dwelling. I've got 25 units. I'm doing optional here. That's going to tell me I can take it at 35%. So I take that 4,969 amps at 35% gives me 1,739. Now, we just put this together. You may want to go 8 runs of parallel. It's up to you, whatever you want to do. But we did 6 parallel runs, and we divide that into the 1,739 amps. That gives me 290 amps. All right. So let's go over to table 310.16 again and look at that table. And if I come down in the 75 degree C column, the next size above 290 amps is 310 amps. Come across, and it's going to tell me I need a 350 kc mil conductor.
Okay.
Now, in the previous calculation in the standard, what was my ground and neutral conductor size? A 1-off. It was, 54 amps or something? And I said 58. I said, if you use just the table, you may think of number 8, but remember to go look at 310.10H for parallel conductors. And it tells you the smallest it can be is a 1-off conductor.
Absolutely.
Okay? Now,
Well, and I just want to be clear, there was a little confusion because I think this was Willie Jackerson tried to make 2 units of multifamily, and they said it had to be 3 or more, but it was just Willie got shut down on that one.
Well, so, and what I want to
that's where that came from, if anybody was wondering.
The only thing I want to point out so far is I haven't changed my calculation method, my
Yeah.
step-by-step procedure. Everything
Yeah.
has stayed the same for standard or optional calculation. The only difference was the number of units and looking at a different table to do it. That's it.
Yeah.
Other than that, I did not change how to get to that point. And then once you
Yeah.
get to that point, then you know where to go and get these derating factors and stuff to apply so you can size that conductor properly.
Yeah.
All right. Now
All
let's
right.
look.
David Englehart's out. Hey, good night, David. Thanks for jumping in here, and feel free to
Oh, you're
listen
welcome,
anytime
brother.
you want. And we love having you in here, Mr. Englehart, Mr. E. We love having you, Mr. E and Mr. G.
All right. Now this is a mobile home, and we're going to be looking at doing the same type of method here. And you're going to see we're going to do the bullet and the check mark here. And I'm looking at this, and I'm automatically thinking, how am I going to start doing my loads? And I think of it because I'm doing a standard calculation here. I do something different when we get to optional, but here I'm looking. I've got an 800 square foot dwelling unit or mobile home, two small appliance circuits, one laundry circuit. And now I'm going to be looking at what loads would I delete from the fixed appliance load. Well, I know the 8500 VA range is not going to be there. The
Yeah.
6000 VA water heater is going to be an appliance. The 5500 VA heating unit, that's not going to be part of the fixed appliance. Then I got a
Right.
500 VA disposal and 800 VA dishwasher. Okay, so
Right.
let's look and see what we come up with. All right, I'm going to look at this. I've got an 800 square foot dwelling unit, 2400, two small appliance circuits, one uh, uh, laundry circuit. Each one of those are 1500 VA, so give me 3000 VA for the small appliance, two of them, 1500 VA for the laundry circuit, add up 6900 VA. Now, if you look, the first, I go back and it's going to tie straight in. Matter of fact, this will probably be pretty good at this point. If I go over, and I think this is interesting for everybody to look at because I know what it says. So, but sometimes it's good for people to see how am I doing the exact same type calculation that I do for a standard calculation when you're giving me all these other sections. Well, the best way to pull that out for you is go over and look at it. So if I take and I look at 550.18A and just say we're looking at the lighting here, it says length times width, mobile home for blah, blah, blah. It says, for example, length width time what? 3. And then if you look at 18A2, small appliance branch circuit, and then you get your laundry circuit in 3, it tells you take it at 1500 VA. Okay?
Okay.
So everybody sort of asks, well, I ask this question. This is where you're going to go to get them sections. It's the same type of principles that we're applying for everything else. Okay?
Dude, I'm just so happy that Willie can calculate his double wide the same as Daniel J's mansion down there.
Oh,
So.
yeah. All right. Now, if you look at 8.5 net volt amps, what does it say? First 3,000 total volt amps at 100%, and the remainder at what? 35%. Well, if I went back and looked at table 220.42, guess what it says? Exactly that. Okay. So I'm just going to take and I'm going to add all that up. And the first 3,000 at 100% is 3,000. The next remainder, 3,900 at 35%, gives me 1,365 VA. Okay. Then I'm going to come down and look at my special appliance loads. Okay. Well, if you look here, I got a water heater at 6,000 VA, a dishwasher at 800 VA, a disposal at 500 VA. Now, if you'll notice here, why did I just go ahead and put the heating and largest motor there? Some will look at that and say, why don't you do that? Well, let me explain why we did that. Because if I go over and let's go back and do some research here so everybody knows where I'm going with everything that I tell you here. If I'm looking at my fixed appliance load and I go over and I look at 550.18 B2, B3, and B4, I'm going to look at all of this, tie this in. If you notice here, for my fixed appliance load, how many of them did I have? 3 or less. If I'd have been
Yep.
4 or more here, then I'd have taken it at what?
50%.
75%.
Oh, 75.
See there? I didn't do any of that here. So I just said, okay, there's no need to add another step here because it's just all going to go together. So I look at what is the largest motor load here. It's the disposal. I'll take that at 25%. Gives me 135 VA. Just add all the loads up together there, and that'll give you 12,975 VA. And then I'm just going to look at my range load. Now,
gotcha.
Now, this gets interesting because let's go take a look at this and see what it says. I'm going to look at 550.18 B5. Now, as I look at this section right here, one of the things that you want to pay real close attention to is what is it going to tell you to do here, okay? So if I look at 18B5 and I come down and I pick it up, you're going to see that it's going to, let me go here for 1 second. I want to add something here. Let's see.
I should have invited Willie because he's better on the mobile home codes.
Mobile.
I'm not that good on it.
Okay.
I do like the two-family home, the single-family home calculations.
Okay, so as I'm looking at this section here, let's take a look at this. Now, I've got 8,500 VA range load. Okay, now this is going to get me back to where I'm going to look at table 220.55. Now, if you look, I'm over 3.5 kW up to 8 3/4 kW. Okay, you remember me doing this 2 weeks ago, I guess? And you come across, and I said, when you're looking at this table, right up at the top, you're going to see demand factor, and it's going to have a percentage there in parentheses for column A and B. So if I have 1 unit, it says to take that at 80%. Okay? Now, if you look...
I'm not trying to stop you, James. Juan makes a good point. He's basically telling me that I should tell you that you a lot of times you're saying the phases, and it's not. It's one single phase. So basically, it'd be called like A leg, B leg. So
okay. Yeah.
That's a good comment, Juan. I've told you that before. It's a standard habit for me too, James. So
I do that. I don't even think about it. I say that's your phases.
Yeah, but it's just something just to clarify for people out there that James oftentimes says phases, but he means the legs of one single phase. So you have an A leg and B leg. James didn't even catch a few times when we were in the thing, Juan. I've been like, hey, is that two phase? Is that two phase? Or is that single phase? And then he's like, oh, it's single phase. I'm like, oh, okay. I just want to make sure, But it's just, we just joke around a lot. And sometimes James don't catch it, but it's funny. He'll catch it like in episode number 27.
Yeah, it's just a habit of mine, just saying phase, isn't it? I know it's single phase, thank you, and then the problem that said that. So as you're looking at this, we're going to take that at 80%. It's going to give me 6,800 VA, and then, of course, I can take that to get my neutral load at 70%. So I'll take the 1,600 VA at 70%, and give me 4,760 VA. Now, all I'm going to do is just add all my phases up here. I had 4365, 12975, 6800. Give me 24,100 VA. Divide it by 240 volts gives me 101 amps. Okay. Then calculate all your neutral loads. I've got 4,365 for my general lighting, small appliance, and laundry load. Then I had my dishwasher there that I checked at 800. My disposal I checked at 5,400 VA. Then my largest motor at 135 VA is 120 volt load, and then my neutral load at 4,760 VA. For the range load, add those up, 10,600 VA, divide it by 240 volts, gives you 44 amps. Okay, so, and I'm not going to go through all the conductors, everybody. We've already done like 3 problems on that. Y'all know where to go and look at table 310.12 also. All right, now that brings me into looking at a mobile home park, and we're going to do this where we're going to do it in optional. Okay, so for this one, I've got 28 mobile homes in this park. Okay, and I'm going to
Okay.
size the secondary electrical distribution system. And what you're going to see, we're going to parallel this 3 times per phase. We got 28 units there, and we're just giving you exactly what each unit's at. We're going to say each one of them are calculated based on load here, typical for a mobile home that the code lot will accept is 17,000 VA. Okay, so I'm
Yeah,
going
and
to
this is like a really important one for like the green apprentices out there, or not even just the green apprentices, but like some of the first time journeymen. Like sometimes your boss will go out there and be like, "Hey, go hook this up," and we got to go calculate this and be like, "Hey, what do we do after the last 13?" You know, like if
mm-hmm,
you can't do this calculation, then you have to make sure that you're covering your ass when you're on these situations and you're just going, hey, I just did the calc on this and you're under by 13,000 watts. So I just wanted to stress the importance of this. I've actually been in this situation before. I did the calculation and they were not even close.
yeah, and
So,
and this is typical. What you'll see that they'll do the calculation at 17,000 VA. Now this one we
yep.
got 28 units. Now if you go look at table 550.31, this is where you're going to pick up the demand factor here for the total number of mobile homes. And if you come down and pick up 25 units, it'd be 22 through 40 come across. It'll tell you can put a derating factor of 24% on. Okay.
Right.
So I'll put that 24% on there, and that'll give me 114,240 VA. I'm done. This is about as simple as it gets. Then you're
Yep.
just going to divide that 240 volts in there. That'll give you 476 amps. And then I'm going to parallel this 3 times, which is going to give me 158.7 amps. And if I look at table 310.16, the next size above that is a 2 aught, which is good for 175 amps. Okay.
Nice.
Now let's look at the neutral. The neutral is exactly the same calculation that I was looking at. The only difference is when I get to step 3, I can take it at 70%. So
Right.
I'll take the remainder after the first 200 amps at 100%, which is 276 amps. Take that at 70%, that gives me 393 amps. And then I divide that by 3, that'll give me 131 amps. Well, we automatically know that if I'm paralleling something for 310.10H, I have to at least put a 1 aught on it, which actually works out for this calculation anyway.
Right.
Okay? And
Yep.
that, my friends, gets you through doing the residential full calculations. And next week we will be starting on the commercial.
Awesome.
Whew,
Dude,
that's enough,
that was
baby.
that was great, dude. Like, I don't think I've ever seen anybody cover it that awesome. Like, that was a really good job. And the
Well,
way you
there's a
did
lot
it,
to cover.
you kind of had to like weed through a little bit of trolling by me too, you know. So, I
Not by
wasn't.
me.
I was trying to help people learn. You know what I mean? Like, I kind of like the whole thing. Like, for some reason, I don't know why. I used to have that thing where when I was talking about residential stuff, I would say phases all the time.
Mm-hmm.
And I'd say, oh, you got A phase, you got B phase, you know. And then one of my apprentices one time, he got backhanded. No, I'm just kidding. But it was like, hey, aren't they legs? Aren't they called legs? You just taught me they're called legs. They're not called phases. But I do that a lot. I say, oh, that's
Mm-hmm.
A phase. That's B phase. Like in commercial, we technically do have 2 phase. You know what I
Mm-hmm.
mean? Because you have a single phase circuit that consists of A phase and B phase, which is 208 volt. So it's 2 separate phases, but we still call it single phase. You
Mm-hmm.
know, and in residential, it's 180 degrees at opposing phases, so we just call that single phase too. You know,
Sure.
so
I'm with
I
you.
appreciate that. That was a great observation, Juan, and I think I've told James that before too. So appreciate it. But let's go to the tool.
Let's cue it up.
It's time for tool review of the week. Sponsored by Electricians Only Tool Review and Nipex Tradesman.
So this is really awesome. Actually, I had a branch that I had to cut up in my backyard, and I actually used this tool. It's the DeWalt version. It's the flex bolt. I actually threw everyone a little curveball from last week because I featured the Milwaukee one to, basically say, this is the one that is comparable to this one. I don't really see any real difference from this one versus from the DeWalt versus the Milwaukee. The only thing I was really amazed with on this one is the power with that Flex Bolt 60. I mean, it felt like it was plugged in, like it felt like a full-on electric chainsaw. They say it actually outcuts a gas-powered one, and I believe it. I mean, it took that branch out quick, and it's kind of small, and it's kind of, just there's some things that you might consider just like a little wonky, not really super strong. But the thing I really liked is over on the right, it has that battery display, and I really like that because when you're sitting there cutting, that's what you're looking at, and with the DeWalt, with the battery power of the DeWalt, you don't even really have to look at the battery power. I went and cut up probably 3-4 branches, and it didn't even break one bar with that. I told James too, one of my reviews, I bought a Flex Bolt, 60 Flex Bolt for $100, and it was a 9 amp hour, and that thing just tears it up. So yeah, so I appreciate it, Jason. Like I say, we try to walk that tightrope and just do the DeWalt one week, do the Milwaukee next week, and so like I say, I don't have too much hate against the red. I just ended up having a bunch of DeWalt stuff, and then that's what I use. So means a lot that everyone joining knows I'm not biased, but red ain't the greatest. But I gave you a free pass.
DeWalt.
Yeah. So I gave you a chip shot this week. Let's see if you can get it on the code question.
All right.
I should have put the answer in how you had it in.
I know this is for DC. That's a GFDI. Matter of fact, they got a new definition for that in 2023 for a GFDI. That's an easy one. I know what you're at.
In your book, it says GFD.
Oh, well, Dad wrote those questions.
Oh, see, there we go. Passing the buck.
I can pass the buck on that, and I know for a fact that they did that, him and Billy, because when we were doing the way we do things, I write the code change book, and then he likes to go in and do the illustrations, get them ready. Then Billy would do the illustrations, then he adds the questions. They do the edit because I start on the other publications. I start updating those, so that's why I know for a fact that's his fault.
Oh, Juan is. Oh yeah, dude, Juan, awesome. Yeah, and like I say, the Flex makes good stuff too. So yeah, I might have to do some reviews on the Flex. I might have to try them out. I might have to just grab my apprentice's drill and be like, hey, let me tear it up for a few hours.
I've never used the Flex. I've never even heard of it, to be honest. I've never.
It's all right. I mean, they got really big fans like really quick, So we'll see. I mean, they're pretty light tools. I do like the weight of them, so that might be something I add in. But Here comes Daniel. Dum, 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 dum. Here comes Jaws coming for the Willie Quiz.
All right, here we go. Let's cue this sucker up.
You are now entering the zone of the Willie Quiz. Enter at your own risk.
All right, so Juan has a comment from the tool that the Flex's pack out is superior to Milwaukee's. I've never heard that before, so I'm going to have to test that theory. I will test that theory, Juan. Mr. G, thanks for bringing that up to me. I appreciate it. I will go check it out. All right, first question of the easiest quiz James has ever faced so far. The first electric light bulb was invented in blank year and later improved to LED in what blank year? Is it A, 1800 and 1981? Is it B, 1820 and 1962? Is it C, 1860 and 1990? Or is it D, 1889 and 1969? Good luck, everyone. All right, Daniel comes out of the gate with B. Ooh, Daniel. Ooh, oh, man.
Daniel and I were thinking on the same things. I was thinking the first LED, not so much, it was LED and circuit boards and stuff was back in the 60s. That's what I'm thinking. I'm not 100% sure on the electric light bulb. I mean, we could go back to the pyramids. I mean, they got things in there showing a light bulb there, but I think it was early 60s. I think I really think.
Ooh, Juan goes B. Ooh.
I'm gonna go B too. I think it's B.
All right. Well, we have 3 different copies this week, and you were all correct. And it was 1820. It was invented, and 1962 was improved to the LED. So awesome job so far.
Was the LED the first one? Was it for like the circuit boards and stuff? Is that correct? Because that's what
it was. I can't remember what exactly they said it was, but it was where they actually were able to put the LED in a light bulb. Oh. It wasn't actually. It was an actual LED bulb. So it didn't say it was a light bulb or whatever, but it was just an innovation.
Yeah, that was in circuit board. That's what I thought. Okay, yeah.
Yeah. It didn't say exactly what. It's basically like it's incorrect to say as a light bulb. The first electric lamp was 1820, and the LED lamp was 1962. So, see,
I was thinking when it was in a light bulb, it was like in 1998 or something like that, I think.
Yeah, that could be.
Okay.
All right, so this is your favorite one, James. You love this one. The electric storage water heater was invented in blank and was not sold widespread until blank. Is it A, 1939 and 1946? Is it B, 1929 and 1944? Is it C, 1881 and 1941? Is it D, 1901 and 1948, or is it E, 1889 and 1945? Good luck, everyone. All right, so Daniel J goes with E right away.
I have a question.
Mm-hmm.
Would the water heater? Would we clarify this? Because I would think the first water heater that was ever done was a commercial one.
So it was what I basically did was, like, I should have probably clarified it better. The first electric storage water heater was invented in blank and then was not so widespread for residential. For consumer use until blank, you know.
Okay.
So that's a clarification. Ooh, Juan has a good answer. Juan came out 1939, 1946. That's a really good answer, Juan. He's got a really good answer there.
Yeah, this is a tough one here because
Daniel J, he's got one.
I was going to say that the water heater probably was really so widespread in the 40s. I would have thought that.
Yeah.
So now it comes down to when they developed an electric storage type of residential water heater. Now, I could be wrong on this, but I think didn't the first water heaters, wasn't they a copper vat? They were copper. Okay, so
very, very expensive.
Yeah, that's what I was thinking. So they did have them available, but only certain people could afford that kind of crap. So, damn, it just comes down to one or two answers that I'm looking at. I'm going to go with D.
D, 1901 and 1948. So you have a really good answer, Jay. Really good answer, James. If you were to pick like a second answer, what would be your second answer?
E.
E. So I don't know what happened. It could have been that I sent it to you wrong or something. But actually the answer is E, 1898 and 1945. So I don't know. I could have sent it wrong to you, or it could have been a typo. But it was actually the Rudd Company that invented the first electric water heater in 1898. Daniel J gets it. Even with James's typo, I think you did a typo on that, but it could be. I think I sent it to you right. That it was 1898. It was invented, first one. Dude, I was blown away. Like when I saw that, I was like, "What?" And then what happened? And I even quizzed my mom on this, and she thought it was like in the 70s or 60s, you know. But what happened was they actually, even though they had the water heater, they started like developing it and everything. They had to use the copper for bullets and everything for World War II for the war effort. And then there was the Depression too. So that kind of, like hurt them. And so they actually did not actually come out with a full-blown, affordable electric water heater until 1945 or after.
I just checked it. You sent it to me as 1889.
Did I? Okay. Yeah. I screwed it up. So anyone who
but I still would have went with D. I knew it was right at the early 1900s or right near that area. So
my bad, y'all. It's 1898. So I sent it to you wrong. Okay, I was getting ready for poker.
Yep. This shit's rigged. Y'all been teaming up on me.
Yeah.
I see what's going on here.
Yeah, well, we're going to have a podcast. Daniel J is going to make a podcast about, how the Stallcup Snyder connection is like cancer of the industry. And, we're going to have to hear about it, but it's all good. It's all good, Daniel. I'm waiting for you. I await your podcast.
All right.
All right, so the first electric toaster was invented in blank and costed blank in today's money. Was it A, 1898 and $50, 1901 and $90, 1905 and $150, 1910 and $110, or 1920 and $75? Good luck, everyone. Oh, Daniel J, he comes right out of the gate with a really good answer. He goes D, 1910 at $110. Really good answer, Daniel. I swear Daniel is he's trying to go for the throat tonight. So, I don't know. James might just copy you on every answer, Daniel. Never know.
This is...
I don't know. James might have he might have to get his own answer on this one, but we'll see.
I'm going between D and E. I think I'm going to go with E. I think it was in the 20s, maybe.
Ooh, they didn't have sliced bread. Ooh, Mr. G.
That's a great answer right then. That should have been on there.
Yeah. Oh, Mr. G. He goes, oh, man, that was good. I like that one.
I was trying to think when they really started coming in with.
And maybe I had the wrong person on that E answer. Juan Gonzalez is saying B, 1901 and $90. That's a good answer. That's a really
I'm gonna go with E. I don't know why, but I think it was in the 20s when they started having these type of appliances started coming out. It could have been before then, but I thought it was in the 20s when we started seeing these type of appliances that you could do things with. So I'm gonna go with E.
All right, James. Well, if you're right, you're gonna take the win tonight with E, and the correct answer is C, 1905, and it was $150 in today's money. So Daniel J takes the win, or maybe you guys tied, but
I only got one right.
Oh, you did? All right,
yeah.
Daniel J takes the win. So awesome that Juan was jumping in and commenting. Like I say, I knew that was gonna fool you, because that's a freaking expensive toaster. And then when they showed it, it was like all exposed metal and stuff. So like there was no really? GFCI protection on that. Like I'll have to post like a thing up there and be like, does this toaster need GFCI protection? Because they didn't dummy proof nothing back then. But it was pretty cool. It was the first toaster ever, and like it only browned it on one side, so you had to like turn it on and then put your toast in and then take it off and then turn it around and then do it on the other side. So it's pretty crazy.
Question bullshit,
dude. I'm telling you, dude. Daniel's oh, dude, he's taking his victory lap. Yeah, I think that's number 3 or 4 for you, Daniel. So, like, we just want you to slow down on the podcast about how screwed up our quiz is, because we don't need that getting out, Daniel. We don't need that getting out.
Y'all freaking team it up on me.
if the competition finds out that we're tag teaming up on Stallcup, it's gonna be a next Watergate. You know, we don't want that. You know, we don't want that getting out. But no, I appreciate everyone participating in the Willie Quiz. Always fun every week. I love putting them together. So much fun.
1 of 3. That sucks. I was
so
good the last 5 weeks. I was 2 or 3 or 3 or 3. Now I go 1 or 2. Bullshit.
I thought I might get you, but nice win for Daniel. Thanks, Juan, for participating. Juan, that's the first time Juan ever participated in the Willie Quiz. So
awesome.
He did good.
It's fun. I guess and see if I can get them or not.
Yeah, it's pretty fun. You can Google them, but I don't think you have enough time.
I don't never do it. I try to guess them, see if I can get them or not. I want to see if I can get it. And usually I rationalize all my answers.
So it comes down to what came first, the outlet or the appliance?
I think the outlet did.
All right. Well, this week's Wall of Shame is from Kevin Muller. Kevin Muller was a guest on here, and he's a inspector in New Jersey. And we really thank a lot for all the people that contribute. And this one's going to blow your guys' mind tonight.
All right, let's roll it.
Shame. 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 Shame.
Oh, you guys are going to love this one.
All right, let's see it.
Dude, how did that even happen? Yeah, you could put conductors in there and splice, but how do you even get
circuit breakers in there?
Yeah.
What the hell?
Yeah, and I even talked to Kevin about this a little bit, and I think he found this like this.
Wow.
I don't even know how they did that.
All right, that's probably my new favorite picture of all. And that's saying something, because we've had some doozies on there back there. I've never seen anything like that.
That blew my mind when I saw it. I was like, oh yeah, Kevin's going #1 on the shame picks.
I'm gonna give you that, Kevin. That is unfreaking believable. I wouldn't have believed it if I hadn't seen it.
Yeah.
Wow.
He said he found it like that, and I was just like, what the heck? Yeah, that was incredible. And the thing is, it just goes to where, how we did the myth on installing breakers in a wet location. I guess that shows you can do
at
it.
its finest, brother.
Yeah, you can install breakers wherever the hell you want, I guess.
Man. Wow.
Yeah,
that is something.
Yeah, that was a pretty good one. I knew that would just seal the deal for our Wall of Shame.
That is a great way to end the segment with that there. That is awesome.
Yeah.
Wow.
So, Mr. G's got to head out. Dude, awesome. Mr. G, thanks for coming hanging out with us. Good night, sir. We really appreciate having you in the chat. So much fun doing it.
Ask any end tour. What are you going to do, brother? You should have left a long time ago.
So there's this segment that I saw by Norm Macdonald, and he says his wife's in a coma, and so then he's sitting there. And he's like, yeah, my wife's in a coma and everything, and I want to, see what figures out. Well, the doctor's like, you know what? I heard that oral sex will, get her out of the coma. I've heard it works, He's like, really? He goes, yeah, just about at least 5 to 10 minutes of oral sex, and she might snap out of the coma. So he's like, all right, I guess I'll try it, doc, So he goes in there for 5 to 10 minutes. All of a sudden he comes back out. He's like, doctor, she's choking. you know. So, you know, like, so, you know, just be, you know. So you just gotta make sure that, you know, you do it the right way, you know what I mean?
We're becoming an X-rated show now.
Yeah. It was thanks to Norm Macdonald, rest in peace, Norm Macdonald. So I'll blame Norm Macdonald. How about that?
All right.
But no, we really appreciate everyone joining every week. It means a lot. You know, we wanted to wish everyone a happy Easter. Dude, did you get the April Fool's joke?
Which one?
Oh, it's coming. No, but they had this one, and it said like every time you have on, like people post something, and it's like a little too long, it'll say "see more," and so you like have to click on the "see more."
Yeah.
It said to avoid being trolled on April Fools, use this, and it was like the little "see more," you know.
All right. Well, hopefully we're on next week.
Oh yeah, I remember that one. Oh, the moth joke, yeah. That was
I know
pretty
what he's
funny.
talking about there,
Yeah,
yeah.
but it means a
Over
lot.
It's coming Tuesday or Monday, Tuesday, whatever day it is next week, you know, so hopefully all communications and everything don't shut down from what some people are saying, so we'll see.
Yeah, so I'm gonna have to do like the last week of April on a Wednesday because we got a meeting, so I won't be able to do Thursday. But
That's okay.
we'll let everyone know. Like, dude, we actually kind of did pretty good on that one, but Juan, yeah, yeah, dude. Dude, we're gonna have like 2 sharks in the water. Like next thing you know, it'll be Daniel and Juan. So it's pretty awesome. Like everyone's gunning towards him. I try to put as many like bogus answers in as possible to make him sound good. But James he's starting to get keen. Like first of the year, I really ramped up, and he went 3 for 3. Like my first one, I was like, oh man, you got all 3. You know, so. I think he's seeing my tactics, you know. So I don't know. I gotta be a little more sneaky if I'm gonna get the king. If I'm gonna get King James, I gotta be a little more sneaky.
You know, it's funny because I go to the pool hall and a bunch of guys, they go, hey, King James. I told them what had happened over, you know, then calling me, oh, what's King James thing? You know, trying to make fun. Now everybody calls me King James at the pool hall.
That's awesome. Yeah, and the thing is that's so funny is that it's like we were doing it like joking, and it's like all the ECD boys are thinking like we're being serious, like I'm your little puppy dog, and I'm sitting there, oh well, King James, you know what I mean? Whatever. It's like, oh okay, dude, if you guys think that, then it's an even funnier joke.
We're making fun of y'all, so what the problem is? Y'all don't even
I was like, I don't care. I was like, whatever. Like, to me personally, it's like, when I bought your 2023 Illustrated Code Change book, like, I thought there could be some mistakes in there because I saw Billy's name on it, you know? And I was like, all right, well, you know, like, all right, you know, like, I mean, you can blame me, you know? Like, you'd be like, oh, that Billy.
Don't see my name on that book.
Yeah, it's so funny. But no, it is a really good publication. I really appreciate everyone joining us every week. It means a lot. You know, like we killed it tonight. We had a really good podcast. And if you guys have any topics that you want us to cover, any myths you want me to cover, whatever, just hit me up. I'm pretty easy to find on social media. I get hit up quite a bit. So, you know, like, you know, people call me and ask me code references and stuff, so I really appreciate it. I try to do them off the top of my head, but like, dude, Juan had an excellent question in Dummies, and I went and looked it up. I was like, okay, here's the answer, and then all of a sudden I realized today I didn't even post the answer, you know? Could have been the first person to post it. I just forgot. I just got busy, you know. But it's a lot of fun to do that, and I really appreciate you, Juan, for posting those out there in the groups. That's a lot of fun to do, and we'll just keep doing them.
All right, let's wrap it up. I haven't eaten today. I'm hungry. I'm ready to eat. I want to get up there before the taco place closes. I want tacos tonight.
Yeah, thanks Daniel J for joining. Thanks Juan Gonzalez for joining. Thanks David Englehart for joining. Thanks all you guys out there in high voltage land. Appreciate you all joining tonight, and y'all have a good week. And remember, make every day an easy day.
Amen. See everybody next week. Have a good weekend. Enjoy the eclipse.